Hello again, everyone. So the next lab is still going to be SQL injection, but in this case, we're going to talk about the second type of SQL injection, which I have tried to demonstrate on this lab. It is SQL injection using Union. Basically, Union is you would have two or more SQL queries that are running, and it would try to output the joined output of the first query and the second query into one. So the way this can be used by attackers is if the database is not properly protected. Obviously, the first thing is input validation, because to do any kind of union injection, you would need some kind of some form of you need to inject some form of special characters. And in that case, uh, it could be a column, or it could also be the SQL statement, right? If you're using union, or that's like special word. So most of the time, there is a way you can actually filter out inputs like that from being entered into an input field, especially if you know there is actually a SQL database that is running and authenticating the user, or a SQL functionality that is actually being accessed. Yeah, you need to do some kind of input sanitization, so no one is able to inject um, this kind of a special keywords for SQL, like union or something. So make it do something, or output information that is not allowed for this particular user. So, and then the most important thing, when if you're trying to do union injection, what you need to pay attention to is, like I mentioned earlier on, union injection is actually joining the outputs of two SQL queries into one. So the first requirement is, let's say, the functionality that you're trying to abuse returns three columns. Then whatever that you're trying to union and get and do SQL injection, it needs to have the same number of the same number of columns. And I'll demonstrate that in a minute. Let's go ahead and log in the simplest way to demonstrate that. So, all right, so I'm logged in as this user, David Duke. So if I go to products, products returns, industrial widget, it gives you a name, description, and a price. So if it basically, what it does is it runs in the backend, runs a query, and just runs a query and say, give me all the products of username dduke. And this is also another vulnerability I was talking about in the previous videos, and there is a that is actually is going to be demonstrated. I'm going to demonstrate that in another video, and it is called an insecure way of insecure direct object reference, IDOR. Because the reason why I'm saying that is because the user is actually being supplied here, and there is no uh, um, authorization checks being done. So there are two things when you doing, like when you're setting up APIs, and I've come across a lot of issues on this. I feel like still there's a lot of developers that are not aware of this, but when you're setting up functionality for API, most of the time they set up authentication, but they don't set up authorization. The problem is this is exactly what you have. For instance, I'm a user. David Duke is actually logged in. Then I can supply another name in here and actually have it run another query. By that, what I mean, let me show you another example. So I said David Duke, I should only be seeing my products, right? These are my products. Maybe this is for a company, and it does have different clients. And that is actually how I designed it. If you go back to the dashboard, you would see the company name is Acme Corp. So if I go to products, I should only be seeing Acme Corp's products. But since there is actually an IDOR vulnerability, I can actually change this name directly and to somebody else from a different company, and I'll be able to see their products. And let me give you an example. Let me go back to suppliers. So if I were to, let's say, this user, her name is Ellen Rich. Now, Ellen Rich has a username eRich. Usually, the thing is, most companies use this convention, right? A first letter and the last name and all this. So usernames are not really, honestly, if you're relying on usernames to protect your database, most of the time it's just not going to work because they use a certain convention. So it's easier to guess. A lot of companies you do that, the first letter and the last name and all that stuff. So in this case, this is from a different company called Global Inc. And user's name is eRich. So let's say D Duke is trying to exploit the vulnerability. Now this is not related to the SQL injection, but I just want to throw it out there because I just want to let you know that is actually a different kind of vulnerability that could be exploited, and I'm gonna go over it on another video. But just to show you, if I were to replace this with eRich. And as you can see, industrial widget and precision gear are the ones that are actually assigned products, or the products belonging to David Duke. But he'll be able to see Ellen Rich's products by just replacing her username in this case. And as you can see, wholesale pack and distribution box and how much the prices are. So this is what is called IDOR vulnerability, and it is because the application is missing what's called authorization checks in addition to authentication checks. Now that's a different lab, so I mean, I've already gone too much on it, but I guess I could have created another video for that as well. But since this is actually obvious, I just want to mention it out here. But the main vulnerability that we're tackling today is SQL injection, right? So let me go back and first off, let me clear this so we can see it better. And I'm gonna go ahead and refresh it. As you can see, this is the request. Let me send it a repeater, and as always, I'm gonna send it multiple times. So if I need to change anything, so let me start from this. And as you can see here, it does obviously it runs some kind of a query in the back end and gets information, right? If I were to do this, and it returns the products, as you can see here. Now what I'm going to try to do is actually I'm going to try to run another kind of SQL injection called union injection, and try to see if I can do union with another table that I'm not allowed to access. In this case, if we go back to let me go back to here and let me duplicate this. And if I were to go back to the dashboard, and if I go back to the main application has a login separate from supplier's login. Now, me as a supplier, I don't have access to that, right? If I were to type Duke is not, doesn't, I might not even exist in here. That's how it is designed anyway. So users, those are separate tables. I might have used the same names sometimes on some logins, but that's not because those two tables have any kind of association. It's because you use the same names most of the time. It's because this is just an example database. But in any case, what I'm going to try to do is I'm going to try to do a union injection, try to get information from a separate table that I'm not allowed to do. In this case, from this table that has a login information of users, not suppliers, and I'm part of the suppliers. So when doing that, first thing, let's go back in here. As you can see here, the best way to do any kind of when you're trying to do any kind of injections, if the request is actually a GET request, and if you have an option to actually convert it to a POST request, that would be the best option. And the reason is most applications, if the URL or the parameter is being passed as a URL parameter, and you passing some kind of special characters, most of the time it won't pass. uh, uh, the application or web application firewall a lot of times would block it. Even applications, for instance, this application that I'm using right now is obviously Spring Framework, and it does use it is running inside Eclipse, and obviously it is using embedded Tomcat. Now Tomcat has its own input validation. So if I try to inject any kind of SQL injection payloads here, because I'm gonna get, and I'm gonna show you that in a minute. So as a matter of fact, let's go ahead and try to do it. So the first thing I try to demonstrate, like I said, when you're doing SQL injection, you need to pay attention to two things. SQL injection using Union anyway. So as you can see here, this is obviously running a SQL injection and retrieving three columns. So whatever Union injection you're doing, another query that you're running, you need to make sure it has the same number of columns. If you don't, you're going to get a SQL error. And the other thing is the two tables or the two SQL queries that you're trying to actually union, they need to have what's called collation. It's basically how uh, uh, the, the different fields, and let me show you by an example. If we go up here and let's say we look at S products table, as you can see here, if you run this query, show full columns from S products, it would give you a column called collation. It's basically kind of like encoding format. So some fields would have certain encoding format. And for instance, supplier username, name, and description have encoding format called UTF-8 MB4 underscore Unicode underscore CI. So if you're trying to do union injection and you have one table on the left side and another table on the one query on the left, obviously you can think of a query as a table anyway, but if you have one query on the left side of the union and another query on the right side of the union, and if they have fields, and if any of the fields have a different formats, let's say if this one is using UTF-8 as you can see it, and the other one is using different format, then you're gonna get an error, SQL error, collation error. So it's not gonna work. So in this case, I made the lab, yeah, a little convenient, but there is ways even to bypass that. Like you can force it to have, you can have, force to have, you can force the output to have all both the combined or the union fields to have one collation. Because when you do union, like I said, because you're basically constructing a table, right? The query is gonna you can think of it constructing another virtual table, whatever query that you're running. So if you have one table and you're trying to and you have another table on the right side and one table on the left side, you're trying to do union, they need to have the same number of columns or it's not going to work. It's not within the format of how a SQL the structural language is defined anyway. They need to have the same number of columns, and obviously like I said, they need to have the same collation. So now that we figured that out, the reason why I explained it is because I'm not one of those guys who just like, oh, okay, just use this payload and it works. I mean, it makes sense. It doesn't make sense. If that's the point, and it's not, honestly, it's not teaching for me. And also, uh, you learn a whole lot better and also be able to test a lot better if you know what goes on behind the scene. Because whatever pen testing that you're gonna come across in the future, if you're doing pen testing or any kind of application testing, maybe application security engineer or pen tester, uh, you might not be able to run all the public payloads that you find in either GitHub or maybe one on Burp Suite itself or something like that. So you end up modifying the payload. If you want to, obviously, if you want to modify the payload, you have to know what goes behind the scenes when running those commands or the payloads. So that's the reason why I usually try to explain that in detail. So that being said, as you can see here, these are there's three columns. So I need to have a query. My query needs to include three columns, even if I don't have a third column from the table that I'm trying to create a union on, there are ways around it. I can have it generate some kind of either random or a null value. But yeah, let's go ahead and try to do it. So now that I explained it better, I feel like I explained it better. Let's go ahead and try to do it. So a union is obviously the first thing you need to do. Yeah, single colon, obviously, kind of like close it, and you're going to use this a special keyword, right? Union, and now what I'm going to try to do is like I said, most user tables would have username and password as their column. It might have now a user table might have more than that. Users table might have more than those columns, but as a pen tester, I might not know that, especially if you're doing it from bug bounty program or something. You might not know that. So, but you can guess some of the columns it would have. If it's a user table, it's probably going to have, most of the time, it would have a column called username, and it would have a column called password. But obviously, I can't guess everything because this is specifically union, right? And if you guess wrong, and if the column doesn't exist, it's not going to return anything. It's just going to give you an error message. So you don't want to you don't want to do that. So if you don't know it, the best thing to do is actually, so obviously, like I said, it has three columns. So your next union SQL query on the right side of the union needs to have uh, three three separate columns. You need to do select something A, B, C, or something, right? It needs to have sector. So, but I want to request only to username and password. So in a situation like this, what you can do is you can do select, and you can do null because you don't know, let's say you don't know the third column. It could have a third column, but you don't know, and you don't want that to limit you. You can just do select null, and you can also use something random like select one. The reason why I actually go into details on this is because I see a lot of payloads out there just without explaining. It just says union select one, blah blah blah. it doesn't it doesn't really explain a whole lot, right? If you need to modify it. But that's the reason why it has select null or something like that. Those columns need to have the same numbers. And since I'm going to be doing selection from a user's table, and I only want two columns, then I would need to supply a third column. In this case, I'm just going to call it null. Select, obviously, null, the first one, then username, comma, password, and I'm going to use from is a user stable. Now, whenever you're sending requests like this, anything that has a space or something like that, what ends up happening is if I were to just send it now, the request would be uh, 400 bad requests because I put a lot of. First off, it does have a lot of special characters. So if you need to run something like this, the best way to do it is you need to URL encode it. Whatever that has the special characters, the spaces. When you URL encode it, it would add that special characters in between, so you don't get the 400 request, bad request. Because let me show you guys an example. If I were to send it right now, it's just going to be 400, as you can see here. It doesn't know it. So it's a bad request. So the best way to do if you something like that, even after doing that, they might. So I selected everything by mistake. I thought I selected only this one, but it turns out I selected everything. All right. So let's try to see if I can send it now. Um, at least you're not getting bad requests or like a 400 bad requests because you are actually URL encoding it. But also it's not returning anything. So the first thing that we need to why is this e-rich? Okay. And like I talked about earlier on, when you're doing any kind of SQL injection, the first thing you need to make sure is you're injecting something, right? And the SQL is bound to have other statements next to your injected variable name. By that, what I mean, if we go back here, when you injecting something here, the SQL statement in the backend is going to say something like select products where username is equals to reach and password, blah blah, and it's going to have more statements. But you want your query to run, and you want the rest of after your injection to be reject or to be dropped down as a comments. So in a case like that, you need to have what's called, you need to have dash dash. You need to have add dash dash, and basically means everything uh, after this particular at the end of this after this whatever dash dash you added is going to be considered as a comments by uh, the SQL statement in the backend. So you need to add dash dash, and also never forget a space, and apply that. Now this looks like a better one because and I'll also show you, as a matter of fact, before I run this, let's go ahead and try to take a look at what query it ran when I actually did it. So it actually errored out. Okay, this is a 1, and that's another problem, you see. So even though it transferred it, it didn't actually decode it before running the query. That's why you might have a problem with going to using a GET request. So I'm going to show you another way, and I mentioned earlier on. So you can bypass the issue where you can't send a query with spaces or special characters by URL encoding, but the problem is, what if the query directly substitutes this value without decoding it? So in that case, that's one of the reasons why the first thing to try and is actually try to see if you can, if it's a SQL injection, try to stay away as much as possible from using URL encoding. That way, you know, the URL encoded value is used before decoding it, right? It would run, if it runs something like this, you won't get the results that you want. You would rather it convert it to decode it first and run the query first. But the only way you can do it that way is if the backend is set up to accept the URL encoded and decoded first before it runs the query. But that's not the case in here, and because it expects, like I said, SQL query and not URL encoded value. So in a situation like that, the other thing you can try is um, try to stay away from URL encoding this value. You can convert it to a post request, because if you do post request, well, if you have space or special characters, it's not going to be seen on the URL, so it's not going to have that 400 bad request on it. So because it's part of the body. So I'm gonna go ahead and do is actually change request method, and I can do this manually. Honestly, it's just changing this post and adding the value after the question mark as a body, which is basically what it did. But I also wanted to show you can do it this way. So now that we did it, let's try to see if uh, we can do the union injection again. So that being said, let me go ahead and kind of clear this out so we can also see the back end and see how the process is on the back end. So again, the single colon, and you can use union and select, and we're gonna do null because, like I said, we need a third column, and we're gonna ask for username and password from the user state, and obviously we're gonna comment everything out after this injection injected value, right? So, and you're gonna do dash dash and space, and let's try to see if we can send this now. Okay, we got something 200, and if I were to scroll down, And as you can see, now there's actually SQL injection has happened because it is actually retrieving value uh, uh, from the users table, because this Jack B D Duke is actually, these are part of the users table. See Bridwell, and if I show you, if I can show you exactly that's what the case is, we have a, like I said, we have a separate table for users, and if I were to select this, and as you can see, these are the users. B. Johnson, all that stuff. They are not part of the suppliers table, but this user is able to do SQL injection, Union SQL injection, and retrieve uh, values from that table. And as you can see, it does have other values as well. M. Jordan, Echapa, and all that stuff. So this is another way to demonstrate how SQL injection is being carried out using the Union uh, um, SQL statement. I haven't added this lab yet, and I mentioned it earlier on the other video as well. I've added it to the Docker official Docker app yet, but it's running inside Eclipse. It's just a matter of packaging it. I believe I should probably be able to add it either today or tomorrow, and you should be able to access it and test it yourself. And also, I know some people, and I do too, because in a professional work environment, you might want to do a scan, right? And if you have a dev environment, uh, you might want to do a scan. But my choice is, especially when it comes to SQL injection, I like to be surgical. By that, what I mean specifically, I need to know what I'm sending, and also I want to make sure it doesn't take out the service in the process, because uh, uh, a lot of the scans, I'm sure if you've done it in a professional environment, you would notice a lot of those scans are actually resource intensive, and they send the payload one after the other, and there is a high probability, even if you don't have SQL injection, there is a probability you might actually overwhelm the service, because especially if it's a production environment, you got to think of it this way: there are actually regular users trying to log in, do some kind of database, uh, carry out some database actions, right? Retrieve data, or they access some kind of API that retrieves data. And that is actually kind of adding more payload. And of course, your scanning will add more payload, because it sends a large amount of payloads by changing, the different the position of the column and all that stuff, and also uh, the payloads, the different kind of payloads. So I don't like to do that most of the time, and especially if you're testing on a production environment, because you might end up carrying out by yourself, in an attempt to actually identify vulnerability. You might do denial of service, so that's not good most of the time. So but if you have a dev environment, you can do that. I think most companies allow you to do that. It's still, even that is just overwhelming the service and taking down uh, the dev environment server. It's still not, still won't be seen as a good thing. Of course, there's also, you might show that is actually, if that is possible, you might show, okay, there is a way to carry out a denial of service. But most bug bounty programs, they don't allow you. They know you denial of service actually exists, and they use a special I mean web application firewall to block against that, and there's also rate limiting and all that stuff. But yeah, today's video is about demonstrating the second type of SQL injection vulnerability, and I'll also add more vulnerabilities related to SQL injection in upcoming videos.